friends, welcome to next video. In this video we will discuss about next topic, that is viscosity. You all knows about friction. Viscosity is also one type of friction, but this is present in fluids. Let we check this example. These are the two layers of fluid. This is moving with velocity u and this is moving with velocity u plus du. So there is relative velocity between these two layers. There will be viscosity. So this layer will impact force on this layer, and this layer will impact viscous force on above layer. So I can write shear stress. This layer will impose shear stress on next layer, and the below layer will apply shear stress on above layer. Shear stress is nothing force per unit area. So I can write shear stress is proportional to relative velocity between these two layers, that is du, and inversely proportional to distance between these two layers, that is, this is du and that is dy. So I can write tau equals to mu into du by dy. This mu is proportionality constant and it is known as coefficient of dynamic viscosity. Now let me first find dimensions of this mu, coefficient of dynamic viscosity. I can write mu equals to tau into dy by du. So tau is force by area, force per unit area, into dy. Dy is distance. I can write length, and du is change in velocity. I can write this length into t power minus 1. This is length by time. So length goes, it will come force area is length square, and this t will come here. So this is force time by length square. So I can write mu equals to Newton second by meter square. This is the units of dynamic coefficient of viscosity. And there is one more coefficient of viscosity, that is kinematic coefficient of viscosity. It is denoted by nu, and this is nothing but a ratio of dynamic viscosity divided and density. So I can write kinematic viscosity equals to dynamic viscosity by density. So if I calculate dimensions of kinematic viscosity, I can write dynamic viscosity, and that is Newton second by meter square, and this divided by density. Density is mass by volume, that is L cube. So I can write Newton is m1 L1 t minus 2, because this is the dimensions of force, it is the unit of force, and second is t1 divided by meter square, that is length square, into mass, that is m by length cube. So cube and square will go, and this will come, and mass will go, and this will come length power 2 length square and time t power minus 1. So I can write length square by t, or I can write meter square per second. So these are the units of kinematic viscosity, and you have to remember in dynamic viscosity, you have to remember this unit. 1 poise equals to 1 by 10 Newton second meter square, because this is a common unit which is used in questions, numerical problems. So, and this in kinematic viscosity, you have to remember 1 stroke equals to 1 centimeter square per second, or you can write 10 power minus 4 meter square per second. So this is all about viscosity and types of viscosity: coefficient of viscosity, dynamic coefficient of viscosity, and kinematic coefficient of viscosity. Or let me check variation of viscosity with temperature. For liquids, mu is mu naught into 1 divided by 1 plus alpha t plus beta t square. Alpha and beta are two constants. These are both positive. So for liquids, this dynamic coefficient of viscosity will increase with temperature. sorry, this will decrease with temperature, because this term will and for gases, this term, whole term, will increase with increase in temperature. So viscosity will increase with increase in temperature in gases. Actually, there will be more collisions when there is increase in temperature. That is why viscosity increases with increase in temperature for gases. Now let me start some simple examples. So this is the question: if the velocity distribution over a palette is given by u equals to 2 by 3 y minus y square, in which u is velocity in meter per second at a distance y meter above the palette, determine the shear stress at y equals to 0 and y equals to 0.15. Take dynamic viscosity of fluid as 8.63 poise. So I will calculate it for y equals to 0, and you can calculate then it for y equals to 0.15. First of all, I will find velocity gradient. U is 2 by 3 y minus y square. So velocity gradient will be du by dy, which will be 2 by 3 minus 2y. Now du by dy at y equals to 0 will be 2 by 3, and this term will become 0 minus 0, so that will be 2 by 3. I have to find which is at a distance y, determine the shear stress. I have to find shear stress, that is tau. I know shear stress is mu into du by dy. Now mu is given, that is 8.63 poise, so that will be 8.63 divided by 10 Newton second meter square by meter square. Now I can find tau at y equals to 0 equals to mu is 8.63 divided by 10 into du by dy at y equals to 0, that is 2 by 3, which comes out to be 0.667. Let me solve this example. A pallet 0.025 millimeter distant from a fixed pallet moves at a distance 60 centimeter, moves at 60 centimeter per second, and requires a force of 2 Newton per unit area. To maintain this speed, find the fluid viscosity between the two pallets. First of all, I will write here given data. Given is distance between this fixed pallet and this moving pallet, dy, that is 0.025 millimeter, which is equal to 0.025 into 10 power minus 3 meter, and velocity is u, relative velocity. It has 0 velocity and it has 60 centimeter per second, so relative velocity will be 60 centimeter per second. So this will be 60 into 10 power minus 2 meter per second, which is equal to 0.6 meter per second. And also, and tau is shear stress is given 2 Newton per meter square. Shear stress is force by area, so this is given, it needs 2 Newton per unit area, that is 2 Newton per meter square. Now I have to find viscosity, so I can find it easily. I know tau equals to mu into du by dy, so I can write 2 equals to mu into du, that is 0.6 by dy, that is 0.025 into 10 power minus 3, which comes out to be 2 equals to mu into 2400. So mu will be 2 divided by 2400, that will be 8.33 into 10 power minus 4. Sorry, this is 24 3 times 0, this will come 8.33 into 10 power minus 5. Hope you understood this. In next video we will solve some more examples. Thanks.